So welcome to the next section, which is all about modules, code reuse, and I'll actually add the word Python packages to this set of things. So I kind of want to zoom out on some of like the goal of what we do when we write code. So maybe you're interested in data science because that's kind of my go-to example in a lot of situations, and you heard about something called NumPy for doing scientific computing in Python. Or maybe you heard about something called TensorFlow. So you wanted to run some code in Python, or maybe you heard of, I don't know, something like you needed to do some plotting, and you heard about this really cool thing called Matplotlib, which is kind of the quintessential visualization platform for Python, but you don't quite know what these things are or how they work. So the topic for today is I want to bridge the gap between what some of these things are and actually how they're implemented behind the scenes. So before we jump into things like Flask, which Flask, I think it's flask.palletsproject.org. We'll play the game of if I remember how some of these things are named. Okay, no, that's not it. Flask Pallets Project. Help me out, Google. Help me out. Yeah, there we go. Oh, .com, not .org. Okay. So tomorrow, we're going to be getting comfortable with something called Flask, which is going to be a web development framework that we're going to use that is also implemented in the same Python packaging, scaffolding that we're going to talk about today. So far, we've thought about things as just being these individual files. So we had rps.py, which contains a bunch of Python code. We also saw that we could have this test rps.py, which also contains a bunch of Python code. Maybe you remember from earlier in the semester where I even said that there's like Python packages that contain millions or tens of millions of lines of code. So question for the audience, do you think 10 million lines of code is in a single file? Like, do you think somewhere out there, someone is distributing a version of rps.py that contains a million lines of code inside of it? Maybe think about it for a second, but the answer is no, absolutely not. That would be absolutely insane. I've heard horror stories where that does happen, but we don't want to be friends with those people. What do we do instead is that we usually think of break our code into a series of files, then write something called a module or a package to distribute that. What does that sound like? Break our code into a series of files, then package something. So in other words, a Python package is to a folder what a Python script is to an individual Python file with typically a .py extension. So instead of working with individual Python scripts today we're going to get some practice working with Python at this higher level where we have a collection of Python code organized into a folder. So let me kind of demonstrate this real quick in my notes directory. Let me go ahead and maybe say like make a directory called my package or something like that. So we've said quite a few times that if we had some code right here, and if we were to like import some of the contents of something, so I think lesson 07 should have just two things inside of it. Lesson 7 should contain a function for read groceries and a function to write groceries out. So let's kind of replay that again in slow motion. I activated a Python REPL. I said import lesson 07, and that gave me access to this new lesson 07 thing that I could then call a function of it on. So if I were to call lesson07.readGroceries, it should return a list of dictionaries containing all of the stuff that we expected in the groceries file. Okay, so this is pretty cool. The generalization of what we just saw here was the idea that we could import from a package instead of a file. So there's a few steps of scaffolding that you usually have to do, which I will demonstrate real quick. I will cd into my package. I will create a couple files. The first is this __init__.py. So now there's a thing that contains a single line of code. While I'm at it, and just because we usually have seen this thing called main, __main__.py, but maybe we haven't quite known exactly what that thing is. Now we're going to see that the dunder main is actually called the entry point for a Python package. So what if I just use nano and I put something inside of that main, such as print hello world from a package exclamation point, close that out, control right, O, enter, control X to close, ls. So now inside of main, we have this print hello world statement. If we go back down, so far we've seen this idea where we can launch Python, the Python interpreter, with respect to an individual Python file. But what happens if I run Python 3 with my package now? What do you think is going to happen? Well, we've said that there's this thing inside of the main, the __main__.py. So I bet what we're going to see is now we're going to see hello world from within a package. So here's what we've done. We have created something where we can organize our code into a series of files. So now let's imagine that we have like what might we have inside of here? Like maybe some adder or maybe some math functions.py. Maybe we open up the math functions.py and we define something called adder, which takes an x and a y and it returns the sum of x and y, and just say return x plus y, def multer x y, return x times y. Fix my typo up here from a second ago, return x plus y, control O, write that out, control X. So now we have math functions. We have this math functions, and now the idea is that we can refer to these functions from within other places inside of our package. So this place that we're currently in is a package called my_package. So now, what if we were to modify the main module, now that we sort of know what that thing is, and we say from my_package dot math functions import adder. First of all, let me try to make sure that this works correctly. cd dot dot. Okay, Python my package. Oh, try again. Python 3 my package. Okay, no module named my package. What did I forget? I think what I forgot is that now I have to actually launch this thing in module mode. So Python 3 -m my package. There we go. This -m flag is kind of a little bit of a bookkeeping operation. Maybe as another point of reference around that, you can actually do this with a lot of different modules inside of Python. So we've been using this thing called unit test quite a bit. Unit test actually also implements its own main method. So Python 3-m unit test, which should actually run. I think when I hit enter, it's actually going to run all the unit tests inside of test.rps.py. And sure enough, that's what happens. So that's a little bit of a bookkeeping operation. So let's talk about what we've done so far. We've created this new thing called a Python package, and we've said that when we use a package, we can split our implementations into a series of files. And the nice thing about a package is that those functions that we create inside of those individual files can then refer to one another. So from within my package, we could look inside math functions and see that we defined two functions. But furthermore, we can then refer to those functions inside of the main module. So the goal of packaging is that we can split our code into a series of files that can then refer to each other, and a lot of the times this is a much more convenient way to distribute things, because you can send someone a folder, kind of much easier than you can just send someone a bunch of files and then tell them to reconstruct things themselves. And it also lets us break our code into some logical groups that can then be grouped into different files that handle different things of our code. So our goal for today, and I don't want this to be like too scary of anything, so let me just kind of make a commit right here with this my package, maybe confirm it's inside of my staging area, git commit -m, add an example Python package, just so we can understand the scaffolding. So the goal for today, which let's go back over into our game history, or our starter repo right here. So the goal for today is that I want to refactor or recreate rps.py as a Python package. So step one for this, and feel free to follow along, mkdir, I'm going to say like RPS package. The name doesn't technically matter, but I do want to differentiate it between RPS package and RPS for a moment. I'm going to move, step two. So step one, let's think of it as create a directory. Step two, is create the underscore init and underscore main.py. So those are our touch commands. So let's do touch RPS underscore package underscore init touch RPS package underscore main.py. Let's do ls or tree RPS underscore package. Cool. So we have one step done already. Next step, let's move a couple of the scripts we've written so far. So I'm going to move rps.py into rps underscore package. I'm also going to move the test RPS into rps underscore package. So now we have a folder, tree rps underscore package, which contains all of our code inside of it. So at the moment, so we've sort of broken our code here. So let's see. So notice that a lot of things are different. Even if I do git status, it's probably going to yell at me saying that a lot of files have disappeared and it thinks that I've deleted a few of these files. We're going to fix that in just a moment because we're kind of in this intermediate state where we've broken our code. What happens if we do python 3-m rps underscore package? So nothing's going to happen. So now let's also, and the reason for this is that now the logic that we were previously keeping inside of that underscore underscore main inside of rps.py is now not inside of the main module. So this thing we were previously saying, if underscore underscore name equals main, we're going to remove this. We are going to put that inside of main. It's a little bit silly to say if name equals main now because we're kind of vacuously, it's kind of vacuously true that we're inside of main. Now what we need to do is we need to import the main method, or excuse me, the main function. So now there's a function inside of rps.py called main. So now from here, let's say from rps underscore package dot, and here's where autocomplete is going to be really nice for us in Visual Studio Code. So let's do that in slow motion again. From rps underscore package dot, so what file do we want to pull out of the RPS package? Well, we want to pull something out of RPS. What do we want to pull out of it? We want to import main. So notice, this is pretty much everything that we previously had over here. So we have successfully moved some stuff out. Let's see what happens if I minimize this over here and then run python 3-m rps underscore package. I bet we should see that we can now start playing the game again. Sure enough, it asks me for a choice, paper, and there's all of our code from previous. So that's more or less what I wanted to tell you about today. Let's do a tiny bit of cleanup where we kind of confirm what some of these things look like. I'm just going to say git add everything because what should happen, according to Git, is that we haven't actually removed any of things. Really, we've just kind of created a couple new files and we've renamed these things such that rps.py is now a part of the package. This would also be a good time to run the unit tests. The unit tests are going to change very slightly, but I think we have a note in our README that's kind of been hiding in plain sight this whole time that we can run the unit tests with this -m flag exactly the same as we were doing a second ago. So let's python 3-m unit test. This is loading the main module of unit test and testing our code. Oh. Let's actually fix that while we're thinking of it real quick. Okay, so python 3-m unit test did reveal there was an error, and that error was that there's no such module named RPS. Okay, let's do some live fixing. So test rps.py, it says that we tried to import RPS right here, and sure enough, if we scroll up, it says that test underscore rps.py, line 3, it tried to import RPS, but it didn't find it. Okay, why is that a thing? Let's try to do some pattern matching with what's inside of the main. Okay, why did it not find RPS? What is the difference between the fact that we know about RPS right here, but we don't know about RPS right there? Let's look at those two things side by side. Okay, try to make a prediction. What do you think Alexander's going to do next to actually fix this? Okay, import RPS versus from RPS package.rps import. Okay, let's fix that. So from RPS underscore package, import RPS. So now we have modified the import statement so that we are importing RPS explicitly from this RPS package that we've created. Let's see if that actually fixes it. Up arrow, try running the unit test module again. There we go. Ran 10 tests. Get status, it should say that we've modified something. Let's just fix that by adding it to our staging area, confirming that our staging area contains everything we expect. Let's make a commit saying that we have refactor into RPS underscore package. There we go. Git push. There we go. So more or less, that's pretty much what I wanted to tell you about today. The rest of the stuff that we're going to be doing in the rest of the semester, which maybe I'll preface this real quick, github.iu.edu, i211su2024, Hazel i211 project lecture. One of these should work. So the remaining stuff that we're going to do from this for the remainder of the course is that we are actually going to be working with code in this inside of this package structure. So if you're familiar, so if you kind of get the gist that a package is a collection of Python files with a main script, with a main module, an initialization, and potentially several extra files, you pretty much have everything that you're going to need to walk through the project. So I will clone this real briefly just as an example. Definitely jump into the video for the next part because we will talk about this in a lot more detail. But if you want to compare the Flask app right here, notice it's got pretty much all the same structure. There's something called app.py, there's something called init.py, and there's something called main.py. And it looks like there's some additional submodules with other things inside of them. But the basic structure is pretty much exactly like the RPS underscore package that we defined today. Okay, so that's pretty much it for today. I will catch you all later.